So here we're trying to solve two exponentials. If we can write them with the same base, then it'll work out a lot nicer. So first I need to brainstorm. I might think, okay, 16 I could rewrite as 4 squared, but then 32 I can't write as 4 to a power. So what else could I try? 16 is also the same as 2 to the 4th. Right, 2 times 2 times 2 times 2, and then I go, oh, 32 is the same as 2 to the 5th. So there I can get them written with the same base. Now what I'm saying is 16 is the same as 2 to the 4th, so before, if this was 16 to the x plus 4, this would be the same thing since this is the same as 16. And then what do I do when I have an exponent to an exponent? So if it was like 2 to the 4th to the 3rd, it would be to the 12th because it's 3 groups of 2 to the 4th. So I multiply my exponents when I have an exponent to an exponent. So just be careful, you're multiplying 4 by this whole thing. So this ends up looking like 2 to the 5th equals 2 to the 4x plus 16. Alright, why is that useful? Well, notice since this is an equation, it's saying this whole side and this whole side are equal to each other. If these whole sides are equal to each other and they have the same base, the only way that could happen is they'd have to also have the same exponent. Since the bases match, if the exponents didn't match, they wouldn't be equal. And so I can go right to, well, if the exponents have to be equal, then I know that 5 must equal 4x plus 16. And so that's obviously a much easier equation to solve. So subtract 16 from both sides, you get negative 11. And then divide by 4x to get x by itself, so it looks like negative 11 over 4. And then you can put back in, and even if you just do it in your calculator, 16 to the negative 11 over 4 plus 4 as the exponent, and hit enter, see if it actually gives you 32. So check and make sure it works at the end.